Yes, students, good morning. And now today we are going to discuss Fluid Mechanics, Chapter 10 of Class 11 Physics, Part 3rd. And in this we will discuss variation of pressure, variation of pressure with G or H, that is height. We will discuss about variation of pressure with G or height. So for this, we will consider what? We will consider a vessel filled with water. We will consider a vessel filled with water. Suppose this is the vessel and this vessel is filled with water. Okay, students. Now, a cylinder of height h is kept inside this vessel. A cylinder of height h is kept inside this vessel. Now, look at here, students. The liquid will exert force F1 on the liquid will exert force F1 on the top cross-sectional area of this cylinder, and due to the buoyant force, a force F2 is being acted upon the lower face of the cylinder, and weight mg is the weight, mg is the weight of the cylinder which is kept inside the liquid. So if we consider a cylinder of cross sectional area A. Now, after balancing the forces, what we will get? W is equal to what? Look at here. W is equal to m into g. W is equal to m into g. And do you know that mass can be written as density of the cylinder, that is rho into volume into g, where rho is the density of the cylinder. So we can write it as rho into volume, that is area A we had considered and height h. So volume can be written as A into h into g. This is the weight of the cylinder. Now balancing the forces, since the cylinder is in equilibrium, so whatever the forces, suppose I am taking it as F1 plus mg is equal to F2. Okay, now we can write it as mg is equal to F2 minus F1, and we can, you know that pressure P can be written as force upon area. So we can write it as force is equal to pressure into area. Okay, students. So since the cross sectional area will be same, the cross sectional area is same. So if the cross sectional area is same, then due to different type of forces, the pressures will be different, and so we can write it as mg, that is equal to P2A minus P1A, or we can write it as mg is equal to P2A minus the P2 minus P1 into A. Now look at here, students. mg can be written as what? Mg can be written as rho a h into g, and it is equal to p2 minus p1, and it is equal to a. Now solving it, we will get a to a cancel out, and p2 minus p1, that is equal to rho gh. So we can write it as p2 minus p1, that is equal to rho gh. So dear students, this is the variation of pressure with depth, how the variation is uh, taking place. Look at here, the difference of pressure P2 minus P1 is directly proportional to the height h. Means as the height of the cylinder is going to be increases, means if there is the more height between these two forces, the pressure difference will be more, and if the height is less, then so we can write it here as pressure is directly proportional to h. Pressure, because z is same, density is same, so pressure is directly proportional to h. Now look at here, if suppose I am saying that if the top surface of the liquid, suppose top surface of the cylinder, let us suppose that if the top surface, suppose this is the liquid kept in this cylinder, and the top surface is at the surface of the liquid. If the top surface is at the surface of the liquid, then it will be the pressure exerted on the surface will be the atmospheric pressure Pa, and here the pressure will be P2. So at the place of P1 we will replace Pa, so it will become P2 minus P1, that is equal to rho gh, or P2 is equal to Pa. P1 is what? Pa, atmospheric pressure, plus rho gh. Pa is the rho gh, and the difference P minus Pa, that is called as Gauss pressure. This is called as Gauss. This difference is called as P minus Pa, that is called as the Gauss pressure. So this is all about the variation of pressure with depth, how the pressure varies with depth. So dear students, this difference is called as Gauss pressure. This difference is called as Gauss pressure. Now we will discuss about the Pascal's law for transmission of fluid pressure. Next we will discuss Pascal's law for transmission of fluid pressure. 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 So, dear students, what we will observe for Pascal's law for transmission of fluid pressure, in this we take a liquid, and the liquid is filled in the pipe, and if the pressure is exerted according to the Pascal's law, the pressure at similar heights will be same. If the pressure is measured at equal heights, then the pressure will be same. So what is the meaning of transmission of pressure by Pascal's law? Transmission of pressure by Pascal's law says that the pressure transmitted inside the fluid transmits itself undiminished throughout the fluid. So whenever the external pressure is applied on any part of the fluid contained in a vessel at rest, it is transmitted undiminished and equally in all directions. Undiminished throughout the fluid and is transmitted equally in all directions. Transmitted equally in all directions. So its first application in hydraulic lift. So we want to apply this for practically. So first application is hydraulic lift. Hydraulic lift. We are taking the example of hydraulic lift. Suppose we have taken a pipe of different cross sectional areas and pistons are being placed, and inside it liquid is filled. Inside it liquid is placed, and force F is applied. Suppose this area is a small l and this area is capital L. Okay, then whatever the force experienced by applying force small f, whatever the force experienced by this section or bigger cross section of the piston which is placed inside the tube. So pressure exerted by the smaller section on the liquid. Pressure exerted by a smaller section in the liquid, and it is given by pressure P is equal to F upon A. Now, according to Pascal's law, this pressure P is transmitted to the larger piston of the cross-section area A. Upward force on the larger piston C2. Suppose this piston is C1 and this piston is C2. So the force experienced by the larger piston at C2, and it will be equal to pressure, look right here, pressure experienced by larger the larger section, and that pressure is given by what? That pressure is given by capital P. And that force upon area. But according to the transmission of fluid pressure, we know that both the pressure will be same. So if small p is equal to capital P, then F upon A is equal to capital F upon A. And what capital F upon capital A. Now, what is the force experienced by this larger piston? The force experienced by the larger piston F is equal to F upon A into A, and that is equal to A into F. So we can write it that force is equal to a small f A. This is the force experience. So look at here what you are observing. You are observing that this force, whatever the force experienced F capital A, this factor is being multiplied by a small f. This factor is being multiplied by a small f, and so the multiplied force multiplied force we are obtaining on the larger piston. We multiplied force we are obtaining on the larger piston. Okay students, now this is about the if A, here look at here, if a small capital A is greater than a small a, then capital F is greater than a small f. And due to this only students, what we observe, by the application of very small force we are able to lift very heavy loads on the other side, because this force is going to be multiplied at the C2, at the cross section C2 what we have taken, this force is going to be multiplied. Okay students. Yes students, dear students, look at this hydraulic brake, and this hydraulic brake is also based on the principle of Pascal's law. And in Pascal's law, as we had studied, that the pressure is transmitted undiminished and equally throughout the liquid. So in hydraulic brakes also, in this system, brake wires having high viscosity is put in this tube, and this is the lever system, this is the brake pedal. As we press the brake pedal, the pressure is exerted by the piston on the liquid placed in the tube, and this pressure is transmitted undiminished throughout the tube. Now if the pressure is transmitted, then this side also it presses this piston, which that is wheel cylinder. What is the wheel cylinder? That pressure pushes the wheel cylinder, and as this force presses the wheel cylinder, what will happen? There is the expansion in the spring which is placed here, and due to the expansion of the spring, the forces acts on these brakes, that is called as, these are what? These are brake shoes. So pressure is experienced by the brake shoes, and the brake shoes attaches, or a force is exerted by the brake shoes on the wheel, and as the force is experienced by these brake shoes on the wheel, the rotating wheel tries to stop it, or the rotating wheel stops at that position, and in this way the pressure inside the fluid is being transmitted to the shoes S1 and S2, and in this way the transmission of pressure takes place. Again I am explaining. Suppose we had applied brake, the lever system pushes the vial and the liquid, and the pressure is transmitted throughout the liquid, and as the pressure is transmitted throughout the liquid, then the springs expands themselves. Since the pressure is applied here, so there is the expansion in the string, and the shaft of the wheel is being attached with the brake shoes. This brake shoes tries to cover the what you call wheel system, and the the rotating wheel stops there. So this is the mechanism of hydraulic brakes. Now We will do some certain numericals based on this. Look at here. Yes, students, look at here. Consider a spring having a spring constant, it is 1.75 Newton meter, and a pressure measuring device. A force acting on the piston compresses the spring downward, and the area of the piston is 3 meter square. Find out the compression in the spring if the upthrust force exerted by the fluid on the piston is 12 Newton. The upthrust, so you know that pressure is equal to what? Pressure is equal to force upon area, and the force is given by kx. Force is given by kx upon a. Now the compression is given, that is equal to kx, so x you have to find out. So pressure is equal to force upon area, and F is equal to, so force is, it is given 12 Newton. F it is given as force of 12 Newton. F it is given that 12 Newton is the force. So F and K is equal to, so force upon area, so F is equal to Kx, you can write, and X is equal to F upon K. 12 Newton upon a spring constant K, it is given 81.75, and X is equal to 0.146. X is equal to 0.146 meter. X is equal to 146 meter. So compression in the string is equal to compression in the spring, and it is equal to x is equal to 0.146 meter, or 0.146 into 100 centimeter, that is equal to 14.6 centimeter. This is very basic question. Now the next question we are going to discuss.